Now, just as we build fluency around lines and angles, it's also important to engage students in problem solving around lines and angles. Let's look at a few examples here. Dion sorted figures into groups. The figures shown were sorted into the same group. Which statement best describes the figures in this group? So Dion has to look at these figures and then figure out, well, which of these statements is true? Is it true that each figure only has one obtuse angle? Each figure has at least one acute angle? Each figure has only one pair of parallel sides? Or each figure has at least one pair of perpendicular sides? In this example, students have to focus on lines. The question asks, in which drawing does line M appear to be perpendicular to line K? If students don't know what perpendicular means, it's going to be really difficult to answer this question. What about this question here? A drawing is shown, and the question asks, what does the drawing show? So the answer choices are two line segments that appear to be parallel, two line segments that appear to be perpendicular, two lines that appear to be parallel, or two lines that appear to be perpendicular. Lots of things that students have to decipher here, and a whole lot of vocabulary in addition to understanding the different concepts related to line segments, lines, parallel, and perpendicular. Here's an example where students are asked about lines of symmetry. Lana drew these figures. Which of these figures appear to have both a horizontal line of symmetry and a vertical line of symmetry? So that understanding of horizontal and vertical is going to be really important here for students to be able to answer this problem correctly. Now I'd like you to push pause and think about some of those problem-solving scenarios that we just saw, and I'd like you to think about how you engage students in problem-solving related to lines and angles.